All right. So today we're going to find inverses of matrices. And that'll be all for today, and then we'll save the next lesson for actually using the inverses to solve some systems. So first of all, let's talk about what an inverse of a matrix is. So an inverse of a matrix, we'll call it matrix A, is a matrix that you can multiply by A with the result being the multiplicative identity. So a matrix times its inverse is going to equal the identity matrix, which remember we said has ones down the main diagonal, zeros everywhere else. So if it's a 2 by 2, the identity matrix would look like this. If it's a 3 by 3, your identity matrix would look like this. So obviously square matrices aren't going to have an inverse. So again, a matrix A times its inverse will always result in the identity matrix. So determining if a matrix is an inverse. So in order for them to be an inverse, they have to equal the identity matrix in order for them to be an inverse. So we're going to multiply them. Okay, if we multiply, we get the identity, then it's an inverse. So let's start multiplying. So first we would have 1 times negative 2/3. So that's negative 2/3. And then plus 5 times 1/3, 5/3. Well, if we add those two together, we get 3/3. So far, we have an identity matrix, right? Let's find this one next. So again, first row, second column now. So 1 times 5/12 is 5/12 plus 5 times negative 1/12 is negative 5/12. So that's 0. So still looking like an identity matrix. Let's try row 2, column 1. So row 2, column 1. 4 times negative 2/3 would be negative 8/3 plus 8 times 1/3. So 8/3. That gives us 0. So still looking like it could be an identity matrix. And then lastly, the last row times the last column. So 4 times 5 would be 20/12 plus 8 times negative 1/12 is negative 8/12, which gives us 12/12. So we would get 1. So these matrices are inverses because we got the identity. So yes. All right, now we're going to learn to actually calculate an inverse. As long as you can find a determinant, it's super easy. So for a matrix A, it's got to be a square matrix. So we got A, B, C, D. The inverse of that is going to be 1 divided by the determinant times this matrix here. So you should notice that the values in this diagonal, A and D, just flipped spots. The values here, the sign changed. We went from positive BC to negative. And then AD there to DA here. So let's just kind of walk through this one. So here's our matrix. So first thing we need to do is take 1 divided by the determinant. So remember the determinant, we multiply the main diagonal. So 4 times 1 is 4 minus the other diagonal, negative 6. And that gets us 10. Okay, so our determinant is 10. So 1 over 10. And then we took this matrix, we moved the 1 and the 4 around, and we switched the signs here. Last step is to just multiply. So 1/10 times 1 is 1/10. 1/10 times negative 3, 1/10 times 2, 1/10 times 4, and this is your inverse matrix. So pretty simple there. If you get a determinant of 0, you can't take 1 divided by 0, so it's undefined and you would not have an inverse. All right. So determine if these two are inverses. So we did that at the beginning. Let's just do that again. So again, in order for them to be inverses, when you multiply, you have to get the identity. So row 1 times column 1. 1 times a half is a half. 0 times anything is 0. 1 times a half is a half. Half plus a half is 1. Row 1 times column 2. So 1 times a half is a half. 0 times anything is 0. 1 times negative a half is negative 1/2, so we would get a 0 there. First row, last column, so we'd have negative 1/2, then there's 0, and then another negative 1/2, which is negative 1, This is no longer the identity matrix, so no. As long as you get one that doesn't work, you can stop. All right, find the inverse. So let's repeat the process of what we did before here again. So first we got to find our determinant. So 4 minus 3 times 2 is 6. So our determinant is -2. So we got to take 1 over -2. And then we take our matrix, flip the 4 and the 1. So we have a 1 here, a 4 there. Ooh, that's kind of an ugly matrix. And then change the signs with these two. So -3, -2, and now we multiply. So -1/2 times 1 is -1/2. -1/2 times -3, negative times a negative, so +3 over 2. -1/2 times -2 is +1. And then -1/2 times 4 is a -2. So this is your inverse right there. So pretty simple, okay? Find the determinant, do 1 over the determinant, flip those two, change the sign there, and multiply, boom, you got it. Your assignment's really short. It's just 5 problems finding the inverse. So again, it's a delta math, so you got to go in to your account, find the assignment, complete it. As far as I know, this lesson will be posted for the day before your Easter break. So your excuse me, hopefully I'm not making you tired. So your delta math assignment should be done by April the 14th. When you're typing in the inverses, it's not going to let you round decimals, so you have to type all your answers in as a fraction. So you just use the slash key to do that. So yeah, that's all I got. Keep working hard. It'll be at least a few more weeks, it sounds like. So hang in there. Keep yourself busy by doing some awesome Algebra 2, and hopefully we're back in school soon. Maybe not. But yeah, either way, we'll be fine. Take care.